Cool. So quick show of hands. How many of you have ever been to a notary to get something notarized? Okay, awesome. Oh, okay, pretty much everybody here. So all of you already know how boring and bogus that entire activity is, right? So you need to take this document, go to a physical place, pay $100 and get something notarized. And you do this for stuff like when you're applying for a passport, getting a loan or whatever, with more or less like a once in a lifetime kind of activity, in which case you suck it up and you do it. You go there physically and get something notarized. So that works out okay in those kind of situations. But then there are these kind of use cases. So Spotify, for example, gives discount to students. So now, if you want to apply for this discount, I don't know how much of a discount it is, maybe let's say $5 a month, you won't go spend $100 to get something notarized saying, hey, I'm a student and stuff like that. So that's too much friction already, right? So if you have to go to a physical notary, something like this can't work. So what Spotify instead does is, you tap on this, get started. It gives you a form, you tell which school you are from, you give your first name, last name. When you hit next, you're asked to upload your the photo of your physical ID in your college, right? And based on that, you get that $5 off on the Spotify subscription. So the point that I'm really trying to make over here is when you reduce the friction of proving something about yourself from a physical notary to something like a form like this. This is also like pretty cumbersome. This is not a form that we like to fill every day. It's still friction, but maybe for $5, it's okay. Like if somebody wants to save $5, you're a college student, sure. So the point here being, when we reduce the friction for sharing data about oneself, there are like new kinds of use cases that get unlocked, right? So I want to like quickly also show you some examples. So that's Fantasy Top. Fantasy Top is possible because data from Twitter is readily available over OAuth APIs. So what if you wanted to build something that's similar in nature, but for like TikTok or Instagram, Reddit, and all of these social media? How do you get that information? If that information is readily available, low friction, there are a lot of these use cases that are possible. Like you can't have a form like this each time somebody wants to play a gambling game on fantasy. So you need to reduce the friction to be able to share data. So there are other fun examples as well. Somewhere in between, this app called Receipts went kind of viral on Twitter, in which you are proving how much have you run on Strava, right? There's nothing super useful that you do with it, but just like a show off that, hey, you've run these many miles. But maybe there are like even more fun use cases. Maybe on Tinder, when you're getting matched to somebody, there could be some score that gets established as to what is the percentage match. So basically, just fun things get unlocked as and when you reduce the barrier of being able to share verified information with other apps. That's essentially the point that I'm trying to make, and that brings me to what we are building, which is Reclaim Protocol. Reclaim Protocol is this way to be able to share information about yourself from your user profiles across the internet. Now, what reputation, what credentials, what activity that you've done across apps, you can quickly share them in one tap with the other applications that you are using. So if you're playing something on Fantasy Top, let's say instead of Twitter, they ask you to prove stuff on TikTok, one click, you should be able to share your engagement on TikTok, right? So those are the kind of things that we do, and we are a zkHTTPS protocol. I think earlier in the day we were talking, we heard Wei talk about zkTLS. I think it's pretty much the same thing, but I think zkHTTPS is accurate more technically. But it's the same thing. The zkTLS, what we were talking about today morning, is what HTTPS is. What that basically means is any traffic that is coming onto your browser over an HTTPS connection, you can generate zk proofs for it. And when you can generate zk proofs for it, you can share it with various applications and thereby reduce the barrier, reduce the friction for being able to share verified data. That's what we do. And I want to quickly show, okay. So it's really simple to integrate. So I think that's the main point that I want to drive today is, Reclaim Protocol is live in production today, and there are already applications who are using our SDKs. And it's really just like, 5-10 lines of code in which you can request for certain information that you want from your end users. And I want to quickly show you a demo of what this piece of code is capable of doing. Sorry, before I show you the demo. So on this, you can see the main parameter that you need to change is this application ID over here. So basically what that does is allows you to configure what information you want to have the user share with your application, right? So, and there are a bunch of data providers that we've already deployed on our backend. So the ones that you see with a green check mark are the ones that we as Reclaim Protocol have built ourselves. And there are more than 200 websites out there right now which has been built by the community. Of course, we help out as well, but by and large have been built out by the community. So there are over 200 websites. You can see GitHub, Gmail, Alaska Airlines towards the bottom, Airbnb. These are, mind you, websites that do not expose APIs. They do not have OAuth APIs like what a Google, Facebook would typically have. So without zkHTTPS, this might actually be impossible. With that, let's go into a demo. So I recorded something before I came here, but I'm going to voice over. Cool. Cool. So the first thing that I'm going to be doing on this demo is show you that there's nothing installed. There's no Reclaim Protocol app that has been installed on this device. And I'm going to be opening a demo website. You could check this out yourself as well. This is demo.reclaimprotocol.org. Sorry. Yeah, so you can go to demo.reclaimprotocol.org. Over there, we have this. I think I should have slowed this down. Let me go back again. Cool. We have a bunch of data providers that you can choose from on demo.reclaimprotocol.org. So these are basically some samples that we have. And in this demo, I'm going to be... Damn. Let me do that. That's okay. In this example, I'm going to be choosing Kaggle. The thing that I want you to note about Kaggle is it does not have APIs. We are still going to be extracting some information from Kaggle. And the thing that I want you to note over here is after I tapped on Kaggle, it takes me to the screen and it asks me to continue on an instant app. Right? So what an instant app does is it opens up a web browser. This is just a web browser. It is opening kaggle.com inside this web browser without you having to install an app. Remember, before I showed you this, the screen, I showed that Reclaim Protocol was not installed on this phone. And yet we are able to pop up this browser. This is what an app clip is, or app clip or instant app is, and you are asked to log in inside this web browser. All that this does is it opens up this website, routes all of this traffic through an HTTP proxy. There's nothing too fancy happening over here. I'm not going to get into the technical details of how these proofs are being generated, but what I want you to gather is there's nothing special that this browser is doing except for being able to generate a zk proof at the end, which you'll see in a bit. So I'm just going to log in into Kaggle. I'm just going to hide it so that you can't see my password. It is really a regular login, as you will see. Yeah, it asks me for my 2FA. I'm going to log in with my 2FA. I say yes. So now I have logged in into Kaggle. And the moment I log in into Kaggle, a proof generation starts. So what's happening behind the hood is a zk proof is being generated on the device itself. So the data never leaves the device. The zk proof is generated and stored on the device itself. And it takes about 10 to 15 seconds on a mid-end phone. I have a Samsung S22, which is maybe 3 or 4 years old now. and that took, what, 10, 15, 20 seconds at best. And once the proof is generated, we are redirected back to demo.reclaimprotocol.org, from where we triggered this entire process, and you get the zk proof, which can be verified, and the business logic can continue from there on. So yeah, this is something that is super, super easy to do. Whether you want to extract information from Kaggle, GitHub, Airbnb, Alaska Airlines, doesn't really matter. We have a simple tool to add these integrations as well. And yeah, it's super easy to get going with any data that you want from across the internet. That's pretty much all that I had for today's demo. If you want to learn more, if you want to try to integrate it in any application that you are building, reclaimprotocol.org is the place to go. And I'm more than happy to help in your integration. Thank you. Happy to take a couple of questions. Stay standing. Okay, cool, thanks.
Hilton.